Welcome back. We've been learning how to work with quadratic equations. We worked a lot with factoring last unit. This unit we're going to work on factoring and solving quadratic equations, and we'll learn other methods to solve quadratic equations. But today we're going to focus on how we solve a quadratic equation by factoring. So in order to do that, let's just think back to the zero product property. Anything times zero is zero. So if we can apply that understanding, so let's say we have the equation 5 times b equals 0. Well, I know b would have to be 0 in order for that to be true. If a times 5 is 0, I would know a would have to be 0. And if a times b equals 0, well, I know either a is 0 or b is 0. So that is what we call the zero product property. If a and b are real numbers and a times b equals 0, I know either a or b would be equal to 0. So one of those factors has to be equal to 0. So we can apply that when we have two factored products equal to 0. I know either the first product, x minus 5, has to equal 0, or I would know that the second product, x plus 4, would have to equal 0 in order to make this a true equation, in order to find the solution. So if x minus 5 equals 0, I'd add 5 to both sides of my equation, and I would see that x would have to equal 5. Or if I look at the other factor, x plus 4, if that equals 0, I would see that x would have to be equal to negative 4. So x is either 5 or it's negative 4. I have two possibilities that will make this equation equal to 0. Because if I put 5 minus 5, that's going to equal 0. 5 plus 4 is 9. 0 times 9 equals 0. Or, if I put negative 4 in, negative 4 minus 5 is negative 9. Negative 4 plus 4 is 0. Negative 9 times 0 is 0. So if we try that with the second example, I know either 2x minus 3 equals 0, or I would have 3x plus 4 equal to 0. And then I would solve both of those equations to find out my solutions. So here's how we can use factoring. If we can get into two factored products, we would know that we could solve for x in that case. But we would have to factor these first in order to get our factored products, and then use our zero product property in order to help us find the solutions. So I'm solving both of these for x, and I find that x will either equal negative 4/3 or x is 3/2. We have two possibilities depending on the scenario. So why don't we take a look at these next examples. Solve 5x squared minus 5x equals 0. Well, I want to use the zero product property because if I can get equal to 0, I got to find two products that will make this equal to 0. So in order to do that, I got to do some factoring. First thing we always want to look for is a GCF. Should be always the thing that we look for. So what's a GCF out of this? I can divide everything by 5x. I'm left with x minus 5. I'm going to divide the 5x out of both terms. So now I've got two factored products. I know either 5x equals 0 or the other factor, x minus 5, would equal 0. And when I do that, I know in this case x is 0, or add 5 to both sides, x is 5. So we're always coming back to that major concept of solving equations here in algebra. So that's a very important piece of the puzzle. But now we're adding in that part where we need to do factoring first. Here, solve negative 12x squared equals negative 30x. It's going to be very difficult because I got to find a number that, when I square it and multiply it by negative 12, gives me that same number times negative 30. We can make this problem a whole lot easier if we make this equal to 0. So I'm going to add 30x to both sides, so that I now have negative 12x squared plus 30x, and that equals 0. Now if I can find a way to factor this and get two factors, I can set them equal to 0. Well, I can divide these both by negative, let's see, 12 and 30 can both be divided by 3, and they both have an x, so I'll divide out a negative 3x, which leaves me with 4x and negative 10 equal to 0. So then I know each factor, if I can get it equal to 0, I can find a solution. So negative 3x equals 0, or the other factor, 4x minus 10, would equal 0. And then I solve both equations, divide both sides by negative 3, x is 0. Or this one, take two steps, add 10, and that gives me 4x equal to 10. And then I can divide by 4. And so x would be 10 fourths, 5 halves, or 2 1/2. So my two solutions would be 2 1/2 or 0. Okay? So we've got 4 examples here. Why don't you try those examples on your own? When you're ready to check the solutions, restart the video and see how we get those. So as we take a look at our first example, we want to get the equation equal to 0. And so I did that. And then I want to factor the expression. So 3 terms, it's trinomial. It's back to our diamond that we did last unit. So think factors of negative 18, the sum of 3, negative 3 and 6. So x minus 3, x plus 6. So here are my two factors. Either x minus 3 equals 0, which means x is 3, or x plus 6 equals 0. So x is negative 6. So my two solutions are 3 and negative 6. Okay, so if we take a look at our next one, x squared equals 3x plus 28. I want to get it equal to 0, so I subtracted 3x from the right and the left and subtracted 28. So I'm left with x squared minus 3x minus 28. Once again, we got a trinomial. I want to factor that, so I make my diamond. Factor of negative 28 with a sum of negative 3, negative 7 and 4. So x minus 7, x plus 4 equals 0. So either x minus 7 equals 0, so x is 7, or x plus 4 equals 0, so x is negative 4. On our third example, we had 2x squared minus 3x minus 35 equals 0. There's no GCF. It's already equal to 0. So I'd use the AC method. I multiplied the A value times C. And then I used my diamond to help me find my factors. So product of negative 70, sum of negative 3. So I'm left with minus 10 and 7. And I used the 2x for both of them. Then I had to figure out which one I had to divide it from since I multiplied it over to begin with. So I divided the 2 out and I'm left with x minus 5 times 2x plus 7 equals 0. So I set both those equal to 0, so x is 5. Or in this case, subtracted 7 and divided by 2, I had negative 7 halves, or negative 3.5. And then in example 4, x times quantity 3x plus 14 equals 5. And I guess I'm realizing that I did that one wrong. I'm going to pause the video and fix my work. I guess I made a mistake. All right, problem solved. I had originally thought that equaled 0. I didn't look at the problem close enough. So hopefully you remember to do that from time to time. So I would need to distribute first to get 3x squared plus 14x. And since it equals 5, I'd subtract 5 from both sides. And then I use the AC method to multiply the A times the C. Then I could create my diamond. Found my factors, 15 and negative 1. And I put the 3 into both factors, and then I had to divide it out of one of them because I had multiplied it over to begin with. So good factoring review here, and then with all these problems. And then now the next step after we did all that factoring is now we take each factor equal to 0. And we solve those. We get x equals negative 5 or x equals 1/3. So that's why we did all that factoring last unit, to prepare us for solving quadratic equations. Now just another word on some terminology. Zeros. Zeros of the polynomial function are also known as the solutions. They're called zeros. It's because those are the x values that we find, that when we plug them into our equation, it makes the function equal to 0. Gives us a y value of 0, and it's on the graph where it crosses that x-intercept. So just a different terminology that we come across. Zeros, same as solutions. We'll also talk about them being the roots, the intercepts, just different things we come across in different ways. So we just do the same thing. So I want the function to equal 0. So f of x is this my equation. I want the f of x to be 0. So x squared minus 5x minus 24. So same thing, I'll make my diamond. See if I can factor this. This is negative 24 and sum of negative 5. And I think it would be negative 8 and positive 3. So 0 equals x minus 8 times the quantity x plus 3. And then in that case, either x minus 8 equals 0 or x plus 3 equals 0. And we should see that we get a value for our value of x. Either x is 8, because x minus 8 is 0, or x would be negative 3, because negative 3 plus 3 is 0. Okay, you can try that example below and restart it when you want to see the solution. Notice we have a negative at the front, so I'd suggest dividing that one out first. So restart it when you want to see the solution. Okay, so we substitute 0 in for the g of x, and then I factored out a negative 1, and then I made my diamond from that. Found my factors of negative 30 and 6. It's going to be a product of negative 180 and a sum of negative 24. So I knew that either these equal 0, and since negative 1 can't equal 0, I'll just use x minus 30 equal to 0. So x would be 30, or x plus 6 equals 0. So x is negative 6. And then finally, you got 4 more problems that you can practice. Like I said, if you want to practice them on your own, see how well you can do, pause the video, and then you can restart to see the solutions. All right, so when solving polynomial equations by factoring, a few things to remember. First of all, we want to get that equation equal to 0. Look for a GCF. Factor the remaining expression by any means you know how, and then solve for x. So I subtracted 864. Looked for my GCF of 6. 6 times the quantity x squared minus 144. And I noticed this is a difference of 2 perfect squares. So it's the x plus 12 times x minus 12. And we have a two-term polynomial. Look for that difference of perfect squares. So I know 6 can't equal 0, but x plus 12 could equal 0, or x minus 12 could equal 0. So x is negative 12 or 12. Here there's no GCF, but it's a 4-term, so 4-term we group. And so I divided out an x squared, left with x minus 11 in the first group. Divided out a negative 9, because that leading coefficient is negative to make them match up. And so it left me with x minus 11. I factored out an x minus 11, and then I was left with x squared minus 9. Here's a difference of perfect squares, which became x plus 3, x minus 3. And then times x minus 11. So here I have 3 terms. Either of those 3 could equal 0. So if x plus 3 equals 0, x is negative 3. If x minus 3 equals 0, x is 3. If x minus 11 is 0, then x could be 11. Okay. Another one you might come across is with some fractions. So I added x squared to both sides. I had x squared minus 4/3 x plus 4/9. If you like working with fractions, that's fine, but I decided to eliminate the fractions by multiplying by the lowest common denominator, 9, on both sides of the equation. Left me with 9x squared minus 12x plus 4. Could have used the AC method, but I recognize that this is a perfect square trinomial. Perfect squares in the A and the C, which means the square roots of those, 3x and 3x, minus 2 and minus 2. So 3x minus 2 times 3x minus 2 equals 0, so those are both the same term. So I just have one solution, 3x minus 2 equals 0. I added 2 to both sides, divided by 3x is 2/3. So notice we could have one solution in these, or multiple. So it all depends on the power. It gives us the possible numbers of solutions. So here is c to the fourth. We'd have a total of 4 solutions possible. So I subtracted 100c squared, factored out a c squared times c squared minus 100. Perfect squares, difference of perfect squares, so I factored into c plus 10 times c minus 10. So we got 3 terms that could equal 0. So now this is a double term, c squared equals 0. I could have broken that down into c times c if I wanted. But either way, the only thing that when I square it equals 0 is 0. And then c plus 10 is 0, so c is negative 10 or c is positive 10. Okay, so today we worked on our solving quadratic equations by our factoring skills. You already learned how to factor. We're just putting them one step further by applying the zero product property. Just keep in mind that if you can't factor something, if it's unfactorable, it doesn't mean that there's no solution. All it means is that there's no whole number or integer solutions. We'll find other ways to solve those in our following lessons. Until next time, we'll see you later.